Thank you, Bill, for the introduction. So I'm a fidgeter and a walker and talker, so I'm going to be distracting for everyone, so I'll do my best. So Bill needs a little more credit because he did something that a lot more ACI moderators should do. He got all of us on a phone call a few weeks ago and said, we're not going to do the thing where every presenter has the same 6 slides, right? We're going to talk about what we do beforehand, and we're going to plan it out so it's a useful, educational session, right? So with that in mind, I got the easy topic. I'm going to talk about just the question of what is harvested coal ash, right? You know, there's a lot of words in that phrase, and you know, you might be more used to thinking of fly ash, right? Us in the industry using the word coal ash more as a more modern term of use, at least as it relates to concrete. So that's going to be a part of this discussion. If we need to know what harvested coal ash is, we need to learn about what coal ash is, right? And I'm going to bore everyone here because I think it's important when you're trying to understand coal ash to also just understand what is coal and how do we even get the coal ash from the coal, okay? So that's where I'm going to start. So just hang with me. We'll get to the important part, I promise. So what is coal? Okay, say the obvious thing first. It is not charcoal, okay? Charcoal's from wood. Coal is a sedimentary rock. Kind of interesting. We don't normally think of rocks as being organic, right? Because coal is formed through the coalification process, whereby plant matter millions and millions of years ago in a unique biome called a peatland decays, is submerged in water, more plants grow, they decay, submerged in water, and then eventually some geologic action happens and it's all covered, right? And then over millions and millions of years, it's covered in more layers, there's heat, there's pressure, there's heat, there's pressure, and you start to purify the carbon portion of that plant matter and harden it into a rock. It is categorized as a sedimentary rock. So, you know, think back to grade school, igneous metamorphic sedimentary. That is what coal is. The important thing to note about this process is that it's a continuous process, right? What I mean by that is when you look at coal development, its age and its point in the process of coalification changes the physical and chemical nature of the coal, okay? We break down these different stages into categories that are called ranks, right? So lignite is the lowest rank coal, all the way up to anthracite, which is your highest rank coal, okay? Those categories are defined differently internationally, but here in the US, we tend to rely on the coal's calorific value as the determiner of its rank, okay? So why, though, do these different ranks have different calorific values? Why do they release different amounts of heat when ignited? Well, it's because these different ranks of coal also have different fixed carbon contents, right? So lignite will often only have 30 to 40% fixed carbon, whereas anthracite can have up to 80%. Well, I was just talking about how coal's formed through this decaying of organic plant matter. We understand that's carbon. If lignite's only 40% carbon, what's the other 60%, right? Well, that's, in coal terms, we're often referred to as the volatile matter, right? But in our world, and I think the term that might make more sense when we're thinking about coal ash is more specifically, coal is composed of the organic component and minerals, okay? So the organic component, like we said, that comes from your plant matter, right? It's the fuel, it's what burns, right? Depending on what kind of plant matter it's formed from, it has different names and different categories. That's interesting, but not useful for this discussion. The minerals are really the important part of the coal to keep in mind when thinking about coal ash, okay? Those minerals that are in coal, the non-plant matter part, come from one of 2 different places. They can either be native to the coal itself, to the coal seam. So think of this like the soil that those plants were growing in, right? Like the clay in those soils, right? Or the silica that makes up the cellulose within the plant fibers themselves, right? Or those minerals can be diagenetic. They come from a secondary source. So seawater flooding the peat bogs, depositing salt, right? Notably where chlorides come from, when there are some ashes that have chlorides, right? Or glacier movements that bring shale and other minerals into the coal seam, right? The reason why the minerals is the important part of this discussion is because this is where the coal ash comes from, right? The minerals in coal aren't combustible. They're not going to burn, right? So when you burn coal, what happens to them? They turn into coal ash in a process we'll discuss in a moment, right? And what's particularly important is that the type of minerals that are there and the composition of those minerals is the origin of the type of coal ash you get, right? So if you have limestone in your coal seam, that's high in calcium. You're going to have a Class C ash, right? If you don't have any volatile minerals, if you just have clays, the coal will likely turn into a Class F ash, right? So let's piece all this coal talk together and remind ourselves why any of this matters, right? If you have a lower rank coal, right? A lower rank coal is lower ranked because there's a lower calorific value. It has a lower calorific value because it has a lower carbon content. And instead of carbon, it has a higher volatile mineral content. Those coals tend to produce Class C ashes, right? Class C in our terminology is a higher calcium coal ash, right? So it's there, the calcium is there because it came from the volatile minerals that were there instead of carbon, right? Higher ranked coals, like some bituminous and anthracites, have a higher calorific value because they have a higher carbon, and because of that they have a lower volatile mineral content, and therefore the ashes that are produced from them are a Class F ash. So that's the story of coal, right? Now let's talk about what is coal ash. Well, I started hinting at it already, right? But let's slow down just a little. So for this, I'm going to reference ASTM C618's definition, right? C618 is the ASTM specification for coal ash and raw natural calcium deposits for use in concrete. Previously, this specification was fly ash for use in concrete, right? So as of 2023, this change was made and this definition was added. Coal ash is fly ash and bottom ash, resulting from the process of combustion of ground or powdered coal, obtained either from current plant production or harvested from landfills or impoundments, okay? So big definition, a lot going on it, right? Coal ash is now this name of this category, right, of the parent category. Within coal ash, there is fly ash and bottom ash, right? And coal ash can be used in concrete whether it came from a power plant directly out of the combustion or if it were harvested from disposal. So, if we're going to talk power plant and the origin of coal ash, and we're going to talk about fly ash versus bottom ash, how all of these come to be one thing we call coal ash, we need to talk about power generation, okay? So here's a very basic 2D version of a process flow diagram of a power plant. I know it just looks like a bunch of jumbled shapes, right, but we're going to go through it. So, first is the boiler, right? So the boiler is a multi-story big metal box. And in this big metal box, we inject pulverized coal. You guys like that animation? I worked a long time on it. Let's see it again. Very satisfying. So, this is combustion. We all remember combustion from grade school. It's carbon and oxygen and a spark, right? You do this to create heat. Why do we create heat at a power plant? In order to heat up water that is in boiler tubes to turn to steam to turn a turbine. Great. That's power generation. I'll let someone else talk about that. Combustion, for us, we care about what happens aside from the heat, right? So one part of combustion is creating flue gases, right? So notably, water and CO2 are the predominant ones. We all know the concerns regarding CO2 in the atmosphere, right? NOx and SOx gases are your other two large flue gas, two large categories within flue gases. We're pointing these out for reasons you'll see in a moment because it's relevant to fly ash and coal ash, okay? What else is going on in this combustion? Well, I harped all about these minerals, right? Some of these minerals volatilize, right? That's where some of the SOx gases might come from, for example, from pyrite volatilizing and the sulfur component of pyrite converting to sulfur dioxide, right? But a lot of these minerals don't, and instead, they melt. This combustion is happening anywhere from 1,300 to 1,700 degrees Celsius, right? So these minerals are melting and fusing this massive fireball, right? So what happens? They melt, they fuse into a glass. They're all floating in suspension. Some of these molten fused glasses are heavy, and so they fall. They fall out of the air in the boiler to the bottom. That is where bottom ash comes from. We are very creative in the way we name these things. It's bottom ash because it fell to the bottom. Then there's the ash, that molten glass, that is light enough and finely divided enough that it flies out the top, right? Collectively, everything that comes out of the top we refer to as fly ash. You'll see that I also added a category called economizer ash. That's just a subset of fly ash because the next part of your process flow diagram are a pair of heat exchangers called the reheater and the economizer, and just past the economizer, some power plants, not all, but some power plants have an ash collection point, right? And so they refer to that portion of the fly ash as the economizer ash. Okay, great. Next in our process flow is the SCR. This is selective catalytic reduction. This is basically the catalytic converter in your car. The point of it is to take the NOx gases and bind them, right? The way that happens, though, is before the SCR, the utility injects ammonia into the flue gas stream. That ammonia will react with the nitrous gases on the surfaces of the SCR to bind to the NOx. Why do we care, right? The reason why we care is some of you may be aware that sometimes ammonia can be in fly ash. There is a C311 test for testing the ammonia content of fly ash. That is all based off of power plant operations. If excess ammonia is used more so than needed for the NOx removal, that ammonia can end up in the fly ash. Pointing out because sometimes in harvested plants, you'll find ammoniated fly ash in certain areas. That is not something native to the fly ash. It is a byproduct of power plant operations for flue gas treatment. Great. The next part is the ESP, stands for electrostatic precipitators. This is an array of vertical plates that are charged and perforated. They're perforated so the flue gas can pass through easily. They're charged so that the fly ash can statically attract to the plates for collection. They'll be occasionally pulsed. The fly ash will fall at the bottom. So this is where we get fly ash from. Now we've got all of our different ash collections. We have our bottom ash from the bottom of the boiler. We've got our economizer ash from earlier in the system, and we have our fly ash. The last part of this that we still need to talk about is our SOx removal, right? So there's still sulfur gases in the flue gas at this point. Now I should say there are several different desulfurization technologies. This is just one of them. It's a very common one. It's called a wet scrubber, where the flue gases are pumped through basically a lime slurry so that the sulfur reacts with the calcium in that slurry to form gypsum and hydrite basanite calcium sulfite, a variety of different hydrates, right? Again, why do we care about this in this discussion? Well, that creates a solid waste product that the utility will also have to dispose of. And as we'll hear more about, in some of these landfills and some of these harvested operations, you have to be aware that there may be pockets of these desulfurization solids. Collectively tend to be referred to as FGD, flue gas desulfurization materials. Okay. And of course, lastly, and unfortunately, water and CO2 escape to the atmosphere. So that's coal ash. That's where it comes from. It starts as minerals in coal. Those minerals get injected into the boiler. They melt, they fuse, and they go to different places. So now we can say what coal ash is, what is harvested coal ash. So everyone has seen this graph by now if you've attended any of these sessions before. It might be in these guys' presentation. This is data from the American Coal Ash Association. They do a survey on the production and use of coal combustion residuals, right? This data is just fly ash. They also have data on bottom ash, right? So if we look just at fly ash, the blue line is the production of fly ash, at least since the 1960s. The red line is the use of it, and you can see there is a big gap, right? Also notably, the thing that everyone will say, of course, is that this later portion here in the modern era, it's a much tighter disparity between production and use. That's where all these talks about fly ash not being as available anymore keep coming from, right? But a big part of this discussion is to show you all how more fly ash is becoming available through harvesting. How and where are we getting this fly ash when we talk about harvesting? Well, this gap between production and use, that fly ash didn't disappear, it went somewhere. And largely it was disposed of, right, in landfills and ponds. And apparently there is at least 2,000 million tons of it in disposal, right? And when you can look at the red line for how much is used every year, right? You know, if you're lucky, up to 30 million tons in a year, 2,000 million tons will go a long time, right? So now we're finally getting to the meat of this about harvested fly ash, right? So how is this ash disposed of, the ash that's produced but not sold? Largely in two types of impoundments. The first, often referred to as stacks, what you'll often just hear as a landfill, right? In this type of impoundment, the ash is removed from the plant, is trucked over to the prepared site, where it's deposited and compacted in lifts. The ash is normally conditioned with about 15 to 20% moisture for dust control and for compaction. Right? The other common option is a pond, right? Where it's exactly what it sounds like. The fly ash is mixed and sluiced with water into a pond, into a pit, right? Where it'll then flow out and settle. That said, what all is in these types of deposits? All right, we already talked about how coal ash is the category that contains fly ash and bottom ash. What else is out there? Well, it's all the above. Depending on the utility's operations, depending on how many landfills they wanted to manage at a time, there are some cases where there will be landfills that utilities decide to only put the fly ash. Then there'll be a different spot where they only put the bottom ash, and there's another spot where they only put the FGD solids. But it's also common that there will be commingled landfills, right? So here's an example of a landfilled ash. The sample on the left that's labeled dried is it just sampled straight from the deposit. On the right-hand side is when we screened it on number 20, right? You can see there's a combination of materials, right? The oversize here is a combination of bottom ash particles, or it could be agglomerates of fly ash that, because of the moisture conditioning, bound together. It can be a combination. There could be some gypsum in there too, right? So we'll hear a lot more from the other speakers about the exact processes used to take material that looks like this and make it better quality, right? But this is the starting point. This is what we have to work out and figure out. As an ash marketer, what this means is when we approach one of these harvesting opportunities, they each have to be approached with their own set of due diligence, right? Because every landfill and pond is different. The other thing to keep in mind is that these power plants, they could have passed through multiple different utilities' hands over the years. And those different utilities might have different operational practices. Also, I made y'all listen all about coal and how about the coal influences the fly ash that's produced, or all of the coal ash. A power plant could switch the coal it was burning 5 or 6 times in its history, which means the ash that was put in their landfill will change in composition with depth, with area, all these sort of things. So as marketers, we have to go to these sites and treat them almost as mining projects, right? Where we will lay out grids of boreholes. We will go through them and we will drill and pull out samples at various depths, right? There are multiple different drilling technologies depending on the project and what makes the most sense. Ideally, sonic drilling really helps preserve sample integrity. Direct push is great, but you really have to have a softer material to work with. Split spoon works really well for shallow depths, but is harder to manage at deeper depths. The augers don't like to dig down as deep. And the point of this is that we take these different boreholes and we look at the qualities of the ash at different depths and in different layers, right? So ASTM C618 says you can't have over 5% sulfur in your coal ash, right? So here we're seeing at this borehole, we're looking at the depth and we're seeing x-axis there is sulfur. At what depth is the sulfur changing, right? In some boreholes, we see areas where it looks like there might be a layer of gypsum here. In other areas, it looks just fine, all the way down to 50 feet. So we do this kind of boring so that we can map the landfill so that we can appropriately plan both the right kind of engineering technologies we need for this site, for this facility that we're going to build, and to help us in our quality control planning so we can figure out how to approach these areas. Do we start here and then move to there? All that sort of thing. The end result of this, ideally, is you end up with a product that looks, smells, maybe tastes, I don't know, very similar to the current production power plant's ash, right? At a quick glance at these two electron microscope images, you'd be hard-pressed to know which one was which. In various different compositional analyses, you'll have a very hard time telling which one is which, right? You know, there's a lot to talk about. That amorphous content is not the same thing as reactivity, but when you take a look at two different ashes from, or a harvested versus a production ash from the same facility, seeing that that hasn't changed is a good signifier, right? It's telling us too that they're not changing chemically too much, they're not leaching too much, right? And then when we actually make concrete with these materials, you can see again, fly ash or harvested coal ash and production coal ash from the same facility will give you, if beneficiated properly, nearly identical results, if not identical results, right? And we're seeing still that in the surface resistivity measurements in the right-hand graph, that we are certainly still achieving that pozzolanic reactivity that people appreciate in fly ash, right? And then in terms of ASTM C618, that's our industry's version of a mill cert, right? You've heard me reference the name several times. You'll see, again, nearly identical strength performance, water demand. There will be differences sometimes. Like here you'll notice that there's a slight fineness increase and LOI increase. that is managed and part of our quality control and manufacturing levers. We'll hear a lot more about how that's happened from other speakers. And with that, how do we wrap this up? Harvested ash starts as coal ash. Coal ash starts as the mineral impurities in coal. Their composition dictates the kind of ash you get. When it's ignited in the boiler, they melt, turn into what we call as ash. Coal ash is now the industry term that's broadly used as the collective term for fly ash and bottom ash. Coal ash that was historically not used was previously disposed largely in stacks and ponds. Every one of these stacks and ponds is a little different because of the history of the pond, the history of the operations, the history of the coal burned. And so marketers like us have to approach each one as an individual, unique project. And then once beneficiated, the ash from these landfills and impoundments should perform the same as your straight from the power plant coal ash.